Okay, let's work through questions 1 through 5. It says, in the 1960s, the average age at which a man in the United States first married was 23.3. Some people believe that the age has increased over time. A recent study examined 40 randomly selected men. The average age of marriage for these men is 24.9 with a standard deviation of 5.3. And does this provide evidence that the average age at which a man marries is now higher? Use alpha equal to 0.05 to make your decision. Okay, well, the first thing we should establish is that in this problem, we are dealing with a numeric variable, which is the age at which a man marries, okay, or first marries. So we have a numeric variable. And we have taken only one sample. We have one sample of 40 randomly selected men. So this helps establish a few things. It tells us that our null hypothesis is going to be in the form that mu is equal to some number, and the alternative will be identical to that, except the equal sign has been replaced with something else. So as we look at our problem, it says it used to be 23.3, and we want to know if it's now higher. And 24.9, does that provide evidence that it's now higher? So our null hypothesis is going to be that mu is equal to 23.3, and the alternative is we want to know if it is now higher. So we're going to say mu is greater than 23.3. Okay, and so our answer choice is going to be answer choice B for problem number 1. Okay, whoops. Now that we know it is one sample numeric variables, we can also establish the formulas for standard error, which is s over the square root of n, and the test statistic t, which is going to be x bar minus mu over the standard error. So the second problem is asking, what is the standard error? Okay, so let's go through the problem and figure out what s is and what n is. So s is the standard deviation of our sample, and n is the size of our sample. So as we read, it says we've selected 40 randomly selected men, so our n is 40. The standard deviation of our sample is 5.3, so our s is 5.3. So our standard error is going to be 5.3 divided by the square root of 40. So I'm going to punch that into my calculator, and I need to get 5.3 divided by square root sign 40. I hit enter and I get 0.83800. Okay, so I have 0.8380. So let's go to our answer choices. And indeed, we see answer choice E is 0.838. Number 3, what is the resulting test statistic? Okay, so for our test statistic, we need x bar minus mu divided by the standard error. We have the standard error already. Our test statistic t requires the use of x bar and mu. X bar is the mean of our sample. So let's read our problem, and it says we selected 40 random men, and the average age of these men is 24.9, average age for when they got married. So our sample mean is 24.9. The mu is the value that comes from our null hypothesis, so we're going to use 23.3. So our test statistic is going to be 24.9 minus 23.3, and we're going to divide by our standard error. So to punch this into my calculator, I'm going to leave the value that I calculated for the standard error in my calculator, and I'm going to do 24.9 minus 23.3 in parentheses, and then I'm going to hit the divide by sign and hit the answer key, and that's going to plug in 0.838 in the bottom there, and I get 1.9093. Okay, rounding off to a fourth decimal place, I get 1.9093. So let's check our answer choices, and indeed we see that answer choice E is 1.9093. Part 4 is asking, what is the resulting p-value? Okay, so to look up our p-value, we have to take our test statistic and look in the t-table. Now, that requires that we have the correct degrees of freedom. So our degrees of freedom is n minus 1. So I'm going to have 40 minus 1, 39 degrees of freedom. So we go to our table, and we're going to look for 39 degrees of freedom, and we don't find that. We see 30 and 40 degrees of freedom. Now technically 39 is closer to 40, but as a safety precaution, we always use the lower number. So we're going to use 30 degrees of freedom, and we're going to look for the value 1.9093. So looking for 1.9093, we see that 1.9093 fits in between 1.697 and 2.042. So this means our corresponding tail is going to be between 0.050 and 0.025. So we have 0.050 and 0.025, and our tail is between that. So looking at our signs, we're going to put our signs pointing that way, okay? Or we can say, we can also write it this way. Either way is fine. Okay. Now, we look at our alternative hypothesis and we see a greater than sign. So we don't need to do any kind of doubling. We just leave it as is, and so my p-value is going to be between 0.025 and 0.050, or I can write it this way: 0.025 is less than my p-value, which is less than 0.050. Alright, so let's take a look at our answer choices. And we see answer choice C is the one that fits. 0.025 is less than our p-value, is less than 0.05. Okay, and lastly, the conclusion that we make. Alright, so the question says to use alpha equal to 0.05. So is our p-value smaller than 0.05? And the answer is yes. Okay, we know our p-value is between 0.025 and 0.05, which means it must be smaller than that. So that eliminates all answer choices C, D, and E, which all say that the p-value is greater than alpha. We know the p-value is smaller than alpha, and so that means we're going to reject the null hypothesis. So choice A says this provides evidence that the average age at which a man marries is now higher, and choice B says this does not provide evidence that the average age at which a man marries is now higher. So if we look at our null hypotheses, we see that mu equals 23.3, which means the average age has not changed. But we are rejecting that, so we are going to conclude with choice A. We have evidence that the average age at which a man marries is now higher, and we're going to reject answer choice B. So number 5 is answer choice A. Hope this video has been helpful.